Have you ever left an ice cube out on a warm day? It's fun to watch it melt. It starts as a solid block, something you can hold in your hand. But as it gets warmer, it turns into a puddle of water. This is a state change. The little molecules inside the ice are getting more energy from the heat. They start to wiggle, they jiggle, they dance around. When they have enough energy, they break free from their fixed positions and flow around as a liquid. It's a simple, everyday experiment you can do right in your kitchen, and it's the first step on our amazing journey to discover a new kind of matter. Now, let's turn up the heat even more. Imagine putting that puddle of water into a pot on the stove. As the water gets hotter and hotter, you start to see bubbles. Then steam begins to rise from the pot. We've just made another state change. The water molecules are now moving so fast and have so much energy that they escape the pot entirely. They fly around the room as a gas called water vapor. We've gone from a solid to a liquid, and now to a gas. What happens if we keep adding energy to a gas? If we blasted that gas with tons and tons of energy, something incredible would happen. The atoms themselves would start to break apart. Tiny particles called electrons would be ripped away from their atoms. This creates a supercharged, glowing, electrified gas. This isn't just a hot gas anymore. It has become something entirely new. It is the fourth state of matter, plasma. It's the most common state of matter in the entire universe. So what exactly makes plasma so different from a regular gas? It's all about electricity. In a normal gas, the atoms are neutral. They have an equal number of positive parts, protons, and negative parts, electrons. That balance means no overall electrical charge. They just bounce around like tiny, invisible balls. But in plasma, intense energy knocks electrons loose. Now you get a soup of free-floating, negatively charged electrons and positively charged ions, atoms that lost electrons. That charged mix makes plasma behave in unique ways. Because it's made of charged particles, plasma can conduct electricity. It can also be controlled by magnets. A magnet near a regular gas does nothing. A magnet near plasma can push and pull it, shaping it. Scientists use giant magnets to hold super-hot plasma inside machines. That control is why plasma is so useful. Not just a hot gas, an electrified substance that responds to invisible forces, making it dance and glow. Think of it as a big, energetic dance party. In a gas, dancers bounce on their own. In plasma, dancers split into partners, ions and electrons, free to move independently, creating a buzzing, glowing crowd. That separation is the key. It lets plasma create light to carry electric current and to form beautiful, swirling patterns. Where can you find the most plasma? Just look up at the sun. Our sun is a giant ball of super-hot plasma, and every other star in the universe is the same. Distant plasma furnaces. The immense gravity of a star crushes matter together, creating unbelievable temperatures and pressures at its core. This intense energy strips all the atoms of their electrons, turning the entire star into a glowing, swirling sphere of plasma. The light and heat are born from those plasma reactions inside our sun. That light and heat travel all the way to Earth, giving us warmth and life. The sun doesn't just keep its plasma to itself. It constantly sends out a stream of charged particles called the solar wind. This is a flow of plasma that travels through our solar system. When this solar wind reaches Earth, it runs into our planet's magnetic field. The magnetic field acts like a protective shield, guiding the plasma particles toward the north and south poles. As these supercharged plasma particles crash into gas atoms in our atmosphere, they transfer their energy and make the gases glow. This amazing light show is the aurora borealis, the northern lights. Waving curtains of green, pink, and purple light. Oxygen atoms glow green and red. Nitrogen atoms glow blue and purple. It's a natural work of art, painted across the sky by the fourth state of matter. The auroras are a stunning reminder of invisible forces and incredible energy. From the blazing core of our sun to the delicate dancing lights at our poles, plasma is a major player in the cosmos. It's not just the fourth state of matter, it's the most abundant one. Over 99% of the visible matter in the universe is in the plasma state. Scientists are not just admiring plasma in space, they are working hard to bring its power down to Earth. One of the most exciting fields of research is nuclear fusion. This is the same process that powers the sun. Inside a star, intense heat and pressure fuse small atoms together, creating larger ones, releasing an enormous amount of energy. Scientists are trying to recreate this process on Earth using machines called tokamaks. These are donut-shaped devices that use powerful magnetic fields to contain and heat a gas until it becomes a stable plasma, hot enough for fusion to occur. If we can master nuclear fusion, it could provide a clean, safe, and virtually limitless source of energy for the whole world. Fusion reactors would use common elements like hydrogen as fuel, and they wouldn't produce long-lasting radioactive waste like current nuclear power plants do. The main byproduct would be helium, the same gas we use to fill balloons. We are still facing huge scientific and engineering challenges, but the dream of harnessing star power in a box is a powerful motivator. It could completely change our future. Plasma is also already a critical part of the technology we use every day. Have you ever wondered how the tiny, complex circuits inside your smartphone or computer are made? Many of them are created using plasma. In a process called plasma etching, scientists use a precisely controlled beam of plasma to carve incredibly small patterns onto silicon wafers. The plasma acts like a microscopic sandblaster, removing material with amazing accuracy to create the intricate pathways for electricity that make our electronics work. Without plasma, our devices would be much bigger and less powerful. From the grandest stars in the cosmos to the tiniest circuits in our pockets, plasma is a state of matter that is both beautiful and incredibly useful. It shows us that there is always more to learn about the world around us, even about something as basic as the states of matter. Plasma is a glowing, energetic, and powerful reminder of the universe's hidden wonders. By studying it, we not only understand the stars better, but we also unlock new technologies that can improve our lives and power our future. Think lightning bolts. Think the northern lights. Lightning is a streak of plasma. Neon signs glow with plasma. Even a spark plug makes a tiny burst of plasma. We make and use plasma on Earth, but to see its full power and beauty, look up to the sky and into space. It fills the space between galaxies. It forms magnificent nebulae where new stars are born. It fuels the cosmic engines that make the universe a bright and dynamic place. Understanding plasma is key to understanding how the universe itself works. Now that's what I call wonder.